Hello, hello. So today I'm gonna talk about one of the courses that previously I was teaching during the time that I was a trainer in my ex company. So back in the days, I used to do a lot of training for people. So my last job, it was mostly like most likely I can say that I was a trainer. So in my ex previous company, it means that the last position that I was holding, so I was teaching people to how what's going on in the industry. After that, what are the best practices and so on and so forth. So the course that I'm sharing in the lesson that I'm sharing today, it was one of my favorite lessons. Yeah, is a lesson that if you can understand this one, definitely we can be good friends. So I'm not gonna talk much about it. So let's go to the not the code, sorry, the presentation. So in a nutshell, this one in this lesson, I'm trying to discuss about the things that make the good um coding and product in general. For example, how do you have to code a uh, for example, how you have to infrastructure the thing and this kind of things, and how to have to design your infrastructure and some of the business stuff also. So because not all the time you are doing the, for example, coding hard, doing hard coding, this kind of things. Sometimes when you go higher in the industry, they put you in a leadership position and they will ask you to do, you have to consider the business side of the things as well. So let me go through. Okay. So the most important thing, in my opinion, that for example, to build a good product, okay, as a software engineer, is that you build something that it pass the test of time. So this one, I think the first time I hear this word, it was from Uncle Bob. Yeah. So I don't know, you know Uncle Bob or not, but he's somebody that it was influencing my mindset a lot. Okay. So the things that I consider, so I will go to in detail in any of these things. So is scalability. Okay. Dependency control. I will go in detail about dependency control. The next one is reliability, CI/CD, those kind of things. Extensibility, can you extend the code? Interoperability, can you talk to other stuff? Standardization, and being agnostic. Okay, so this one also I will go in depth. Low barrier to entry and high ceilings. These things, when I was younger, I don't understand. So normally I wanted always high ceiling, but now I'm as getting older, I care about both sides of the things. So I want both low barrier and the high ceiling, and be agile. Okay, so refactoring iteration. On the business side, you want transparency, network effect, gamification, IQ effect, and build for publicity. So these things also, I am not gonna this because this one is a coding channel. I'm not gonna explain these things much. But if you are interested, you let me know in the comments below. I can discuss on the business side of the things first. Okay. So let's go through each of the items one by one. Okay. The first item in the list is scalability. Every time I'm talking about the scalability, this is a graph that I like the most to show. So in this graph, what you see here on the left is this. Okay. The way that you code, uh, it it is very different. There are different approaches for writing code. Normally, for the startups, we just want to make it works, or for example, we just do everything as fast as possible. This kind of things. However, although you will have a very fast development time, but if you, I'm not sure if you have worked in any projects that it is take for many years. But for example, after sometimes you will hit the wall if you do fast fixes every single time. Okay. However, there is another approach also. So this one definitely, in terms of the growth of the code, uh, at the beginning maybe you have a slope, but as you grow, you become faster and faster. When this is when, for example, you do things like reusability and those kind of things, make things modular and so on and so forth. So let me give you some of the examples how you can make the code scalable. Okay. So the first, so for example, microservices, there are plenty of discussion about the microservices on the internet, those kind of things. So definitely something that it make the things scalable. Domain driven design. Okay, so domain driven design changed my life. This one I learned from the Uncle Bob. So solid principles, those kind of things. At the beginning, when I was doing the domain-driven design, I was not understanding what I'm doing, but just only because they were authority and I was following them, I was doing domain-driven design. But after sometimes, after developing the domain, I use this architecture for 2-3 years. After 2-3 years, it start show a significant improvement. It means that I could do things that others people they cannot do, and this was the reason that to some extent I was a big architect in my ex company. So domain driven design is a very important thing. If you are interested on domain driven design, let me know. I will do a video on it. So event-driven design. So this one also is a big thing. So I remember there was a project that I was doing that, for example, I wanted to pass a variable from one place to another place. So passing the environment from here to there and after that to there. But with a message bus, you can easily put the thing inside the message bus and you get, so you have a, you decouple the code. Decoupling the code is very important. So this is something that you have to always care about. When you decouple the code, things will become more reusable, so you can scale things faster. Okay, and rather than, for example, just wiring up the thing and spending a fortune time on just wiring the things with message buses, like for example Apache Kafka, or for example MQTT, or for example even a junky handwritten your in-house code, that it is a message bus is much better that for example not having it. Okay, so for me always domain driven design and message buses, event driven design, this two is always a must, even for example for low level stuff. Even previously I was doing C++, even in those kind of things. Dependency injection, this one is my love, man. So dependency injection, it was another thing that is really changed my life, changed my coding career. So dependency injection is a later I will discuss the dependency and stuff. But the dependency injection, in just in a nutshell, you are controlling your dependencies, and rather than, for example, hard coding everything, and for example everything have a hard dependency, you can switch things around. So this one is very good for testing and those kind of things. If you are into TDD, those kind of things, yeah, you would love dependency injection. Okay, so patterns. Okay, so design patterns, don't reinvent the wheels, those kind of things. For example, CQRS also, it depends. For example, for something like low level, you don't need CQRS. But for example, if you are doing microservices, those kind of thing, command query responsibility, yeah, could help. Okay, so you can separate your commands from your queries, so you have you can duplicate the databases, those kind of things. So yeah, that's fun. So the cloud, yeah, so the cloud also is another one. Test-driven development. Yeah, so when, for example, you have one employee, it is very different than you have 100 employees. Okay, so in the future, for example, or for example, if you have an open source, when you set up a test, many people they can contribute, so you can scale the things. Okay. However, if you don't have a test-driven development, sorry, test-driven, yeah, I'm over. Okay, if you don't have, for example, test, what will happen is that somebody changed the repository. You don't know the things. He is a time bomb. For example, the things is making a issue in the future or something like that. And solid principles, this one is like same, the brother of domain-driven design, and so on and so forth. So yeah, so CI/CD, and test-driven development, those kind of things. Also, these guys, they are brothers. And infrastructure as a code, this one also is a something that it make life very easier. Recently I'm using Terraform and Ansible. They make life much easier. Okay, so these things are the things that help you to make life more scalable. Okay, so let's go to the dependency control. Okay, what the dependency control helps you. Okay, so if you don't have a dependency control, what will happen is that your code would be like a spaghetti. If you want to change something, you have to touch the entire thing. Okay, however, when you have a dependency control, your situation is more like a sushi. So if you want to change something, you just take one sushi, that's all. Okay, so it decouple your services, it decouple your data, and so on and so forth. So for doing for dependency control, what are we doing? We do in dependency injection. So we can switch the services, we can switch the data, and so on and so forth. Clean architecture is another way, because we do a lot of abstraction in the clean architecture, domain-driven design, those kind of things. So is another way to decouple your data and services from each other. So yeah, event-driven design is another way to control your dependencies. Is much easier to, for example, separate a service from another, because they all pushing everything into the same topic, right? So it is much easier, and the solid principle as always. So okay, so the next topic would be maintainability. Okay, so this one, always remember, this is the thing that I always like to say. Okay, developing a code is an easy part of the day. Maintenance is a hard part of the day. Well, you can develop whatever you want, but can you maintain it? Okay, so some of the things that it help on the maintainability of the code, single source of truth, that one is very important. If, for example, your data is scattered all around the world, yeah, this is not something scalable. Okay, so again, solid principle, test-driven development. So test-driven development help you to maintain. For example, you hire an intern. For example, this guy, for example, want to change your code that you wrote 100 years ago. Okay, so when you have tests in place since the day zero, even before you even write your code, you develop your test. Now the new intern, when he write the code, he can test it against your test and make sure that you ship something reasonable. Okay, you don't ship a time bomb that it will screw you up in the future. And another thing that it is in maintainability, back compatibility matters. There is no, you cannot do. The one thing I learned in this industry is that no matter how much we hate the old stuff, uh, it is not good to, it is more costly to develop from new. So you want to always do it in a way that could be back compatible, reusable, and this kind of thing. So some of the issues that you care about the maintainability, and for example, you do test driven development, those kind of things is, for example, what if your employee resign? Okay, if your supplier, for example, or die. Okay, for example, for example, always pays more. We say that, for example, if I abducted by aliens, so aliens. So what would happen? Okay, so and these things is happen. For example, in my previous company, things go EOL, okay, end of life cycle. So yeah, for example, something simple. For example, you're using a package. After that, he break down the dependency. So he do a new update on your package, or for example, your library, and the entire code is get broken. Can you handle that? Okay. So it is very important to handle the dependency. Otherwise, you go encounter this kind of issues. And can you continue the business forever? Okay, so if, for example, you don't control the dependency, these kind of things, your business would be more fragile. What I would say. So reliability. So reliability is the reason that we do the test, and we do the CI/CD pipeline. The reason that I like the CI/CD pipeline is that it protect you. Okay, what I mean by it protect you is that, for example, sometimes even, for example, you forget to, for example, do the test on your side, or for example, you want to add some flair to it, or add a little bit extra sauce beside the test. I don't know. For example, you want to push it to GitHub or something like that. After that, accessing the resources, you don't want to entire company have access to your API key to, for example, I don't know, for example, to your uh, ECR, okay, or for example, something like, for example, Elastic Container Registry. It means that you don't want everybody to be able to push, for example, to your Docker. Okay, so CI/CD is a nice place to keep, to, how to say that, to be more systematized. Okay, so yeah, and do the test, and most importantly, do the test before, for example, pushing and stuff. Yeah, so CI/CD is a nice thing to have. Not nice thing to have, is almost must. Only if you are very messed up, yeah, CI/CD you can skip it. But if you are a company that at least 5 employee, I think CI/CD is time for you to develop already. Actually, for most of my project, even, for example, I do, for example, now I'm doing solo, I still do CI/CD. So infrastructure as a code, so in terms of the reliability is better because how to say that, for example, you go into, for example, imagine you go to AWS, you click here and you click there. Yeah, or can you repeat it? Or for example, do you remember 1 year from now what you did? But when you make it documented over there, for example, you use it, for example, something like Terraform. Okay, so everything is documented, everything is repeatable. So make things life easier, more reliable. Okay, so anything happen, you can just create another instance tomorrow easily. So why this one is important? How reliable is your system? Yeah, is it full of bugs? Can you catch up bugs before you ship? This one is very important. Okay, you don't want to ship code and debug it in front of the customer. So my previous job, we literally debug in front of the customer because we ship it to, for example, to semicon manufacturer, and we have to go there. And for example, sometimes we have to go on site because they don't have internet access. So what will happen is, because the thing is very, they have lots of high secrecy. So for example, some of them, they were defense or something like that. So you have to go inside the factory to fix things up, literally in the factory. And for example, the customer is on top of your head and you are coding. Okay, so man, that is not a nice experience, especially angry customer, they want. Yeah, so that is the reason I take testings very seriously. Okay, interoperability. Okay, so interoperability is the most important thing about the interoperability is that can they talk to each other? For example, the product that you are designing, or for example, this kind of things, can it talk to another things? For example, it is very difficult if you have one product that only use his own ecosystem. But for example, when you provide a product or using somebody's else ecosystem that you can connect to other features and those kind of things, life it become much easier. So plugin system is a solution for this. So yeah, okay. So the next thing is reusability. Okay, so you don't want to reinvent the wheel. Okay, so when you develop something, the reason that reusability is very important is because of the maintenance as well. So although I talk about the maintenance easy, so when you, for example, you reuse something, you write it once. After that, you maintain it in one location. But if you develop the same thing over and over and over again, if for example you just want to add one feature, or you find a bug and you want to fix that bug, so you have to fix it 1,000 places. So don't do that. Okay, so don't repeat yourself. This one is one of the coldest ones. Try to make the things as much as possible reusable. So sometimes this is not good. For example, because of the performance reason, you have not to make everything absolutely reusable all the time. But uh, in general, try to make things as reusable as possible. Another issue with the reusable, this kind of things is sometimes if you want to make things reusable, codes is become very complex, and especially if you hire somebody new, they won't understand it. For example, the best example of this one is generics. Okay, so for example, uh, sometimes generics could be quite mentally difficult to understand. So for this kind of scenarios, reusability, I won't say that you have to be all the way reusable, but reusability is something that it can save you a lot of time, and it can scale your business. So this one is some of the example. Can you use SQL, or should you reinvent the wheel every time? You don't want to reinvent the wheel every time. Can you leverage past for the future? Yeah, so this one is important. Can you leverage past for the future? You don't want to without our past. If for example you want to start everything from scratch, yeah, that would be a lot of wasting time. So standardization, why standardization is important is that when you make things a standard, life it become much easier, because when you write a standard, at least, okay, the best thing about the standardization, for example, imagine something like OpenID. Okay, or for example something like PLC open, in for example in my previous industry. So for example, when you have something like OpenID, okay, you write the documentation everywhere, somebody write plagiarize for it, somebody write the at least, okay, minimum, okay, When you write the standardization, you write the documentation once. And this is amazing. But when you don't have a standardization, okay, for everything, for example, you imagine you have different implementation for the same thing, okay, so you have to create at least two documents, right? But when you standardize the thing, the minimum basic thing is the documentation. But this is more. When you standardize something, you can make an ecosystem around it. For example, somebody make a playground around it. Somebody, for example, write tests for it. After that, somebody how to say that, write a wrapper around it. After that, with standardization, you can do a lot of wrappers. But when you don't have a standardization, you don't have any of these things, and life it become more difficult. And the standardization it makes the reusability much better. However, there is a bad thing about the standardization is edge cases. For example, if you want to do customize for a very edge case, if you are using a standard, for example, something like OpenID, or OpenID is quite well developed, to be honest, in my opinion. But for example, something like a communication system or some sort of protocol or something like that. Okay, if you want to do some sort of customization, yeah, the life could be more challenging. Maybe you put your standardization too open. After that, if your standardization is too open, after that, that is not really a standard. So, but overall, okay. So design patterns. One of the things that I like to, for example, I don't reinvent your algorithms. For example, follow the standard design patterns. The reason that it is that the next person that come and read your code, he knows what you're doing. Okay, for example, he knows that this one is a singleton. Singleton is singleton. Okay, in any programming languages, he doesn't need to learn anything. The learning curve will become much lesser. Okay, but even, for example, forget about others. For example, you read the same code, for example, now from 10 years from now. Okay, 10 years from now, you totally think differently. Okay, so you see your code from 10 years ago. If you use a standard pattern, you say, oh, okay, you easily get it. So don't waste your mental energy on the things that is already so. So the most important thing about the generalization is a muscle memory. People like solution that they are familiar with. This one is very important. So the next is extensibility. Okay, this one is my favorite topic. Okay, can you build a product that ship now, develop later? Okay, so extensibility is all about that. The best example for this one is Visual Studio Code, WordPress, Google Chrome. They have all these extension things, right? So for example, you have a lot of extension, or for example, even the VS Code, we can go over there, and for example, we have all these beautiful extension. It make it much more reusable, right? And rather than, for example, you develop the entire thing by yourself, other people they develop the thing, they customize the thing for themselves. Make life easier. Okay, extensibility is very important. It create a network effect, all those kind of things. Okay, the good thing about the plugins. Okay, I'm very big fan of plugin system. In my last company, I did a lot of plugin system. The next is being agnostic, and this is one of the reasons that I don't like framework. For example, something like Next.js, I don't like it. Okay, because the thing that it is that nothing is God. Okay, in our industry, nothing is God. Everything will be changed. Okay, so when you are, for example, you are committing yourself to something like Next.js. Okay, so, or for example, .NET framework or any framework. Okay, for example, Angular, whatever it is. Okay, you have to dive with it. Okay, be agnostic. Okay, for example, nobody is God. For example, do something that can be changed in the future. Low barrier to entry and high selling. This one is one of the nice things that I learned in this industry. Originally, I was all about high selling. Okay, what does it mean, low barrier to entry and high selling? The meaning of this is that how to say? Okay, so high selling, it means that you can do anything you want. Okay, so you can modify the code whatever you want, you do whatever you want. Okay, but low barrier to entry, it means that easy to start. For example, if you want to write the hello world, for example, imagine something like Python. Okay, how easy it is to, for example, just write a hello world in Python. Okay, however, for example, something like, for example, writing a hello world, for example, in some other language. Okay, for example, in a framework. Okay, for example, something like C#. Okay, so if you want to create a console application in, for example, in a .NET framework, for example, for example, console application, there are many files involved. Or for example, in Java, many files involved. So writing a hello world. So this one is not low barrier to entry. So it has a high learning curve. Okay, but the issue with the low barrier entry is that normally, for example, when we say low barrier to entry, for example, one thing that people they like is low code or no code, this kind of things. Okay, and that is a horrible thing. In general, not a horrible thing. It scales the thing in the fact that everybody can use, but when you want to scale something as low code or no code, life is very difficult. Because is what the customization, those kind of things, for especially for some of them they are well developed nowadays, but most of the low code and majority, okay, they are not really for high selling. It means that you cannot do something super fancy with them. Okay, you want something that it is easy to enter, okay, and it is very customizable, that you can do whatever you want with it. Okay, so this is what I would say for low barrier to entry and high sell. Okay, be agile. So okay, the only constant in life is change. This is very true for your code. Okay, so anything can change. Okay, so and for doing anything can change, you have to refactor and do the iteration. Okay, because why? If you have not to, the main philosophy here is that you have not to see your code as one thing that you develop, after that something passive. Okay, you develop, after that you reuse it forever. Okay, if you do not upgrade the system over time, okay, the things, the issues build up, the how to say that, the performance issues after that. For example, it's just a simple example, your UI. Okay, so if you don't keep upgrading and make it more beautiful over time, after 10 years you will see that, wow, my UI, it is very outdated. Okay, so now you want to change it, man, that would be a very huge difficult. But if you keep upgrading the system over time, you won't have this kind of issues. So this is the reason it's very important to be agile, do refactoring, iteration. So this is and refactoring and reiteration, those kind of things are very hand to hand with the CI/CD and tests and those kind of things. Without those, you cannot do this kind of things easily. So storybooks, I love storybooks. That is love. So yeah. So I think is enough for this video. Please always like, share, subscribe, and I'm looking forward to more videos. If you have any question regarding this video, also please let me know. Anything that you want me to go more in detail, I can create videos about it, but it is all up to you. Thank you.